Section 2.7 is on absolute value functions, and some of this stuff you have not seen before, so some of this is completely new. So let's start out with what an absolute value function is. Absolute value function looks like this: f of x equals the absolute value of x. You know what the absolute value bars do to a number, but we're going to talk about what the function itself looks like. To graph this looks like a V, basically. And over here, the absolute value of x can be written as a piecewise function. A piecewise function, if you don't remember or haven't seen this before, is a function that can be written in different parts. So the absolute value of x can be written in 3 different parts to help you graph it. If we start at the top, it says that the absolute value of x is just x if x is positive. So if x is positive over here, this is the negative side. Over here on the positive side, it's just the line y equals x. And the line y equals x is just a line with a slope of 1 and a y-intercept of 0, because this is like plus 0. So if I y-intercept is 0 and a slope of 1, go up 1 over 1, looks like this, all the way over there. The next part says it's 0 when x equals 0. So at 0, it equals 0. So the point is 0, 0, so it's going to hit right there. And then it says when x is negative, we have the line y equals negative x. And y equals negative x is just a line with a y-intercept of 0 again, except now we have a slope of negative 1 instead of positive 1. So we go over 1, down 1. So on the left side, looks like this. So all in all, the absolute value of x looks like a V, like I said before. It can be written in 3 different parts like this. F of x equals the absolute value of x is called a parent function. That means it's like the main function, and you can do transformations on it to move this V anywhere on the graph. So we're going to talk about transformations. A transformation is anything that changes the graph's size, shape, position, or orientation. And a type of transformation is a translation. And a translation shifts the graph horizontally and or vertically. It does not change the size, shape, orientation. All it does is shifts it. In other words, it slides. So a translation is sliding the graph vertically or horizontally, so over and up. Translating is sliding. So you're not changing the shape of it, not making it wider or narrower, just shifting it. So this is what a shift is going to look like. We have y equals the absolute value of x. If we're shifting it, we're going to add 2 new numbers, an h and a k. H and k stand for 2 numbers. You're just going to put 2 numbers in there. H is how many units it's shifted horizontally. K is how many units it's shifted vertically. And the new vertex, or where the point is on your V, is going to be hk. So let's throw some actual numbers in here instead of just these h's and k's. I'm going to graph the y equals absolute value of x, the graph we were just looking at. The one that has a slope of 1 on the right side and a slope of negative 1 on the left side. And it has a vertex at 0, 0. This is where the point of our V is. So let's look down here. It says graph the absolute value. Now it's just not the absolute value of x. It's the absolute value of x plus 4, and on the outside of the absolute value minus 2. And then we're supposed to compare it to our original parent function of y equals the absolute value of x. The number on the inside of the absolute value is h. It says it right up here. The one on the outside is k. It says that h is how many units it's shifted horizontally. And whatever number is on the inside of your absolute value is always the opposite, because the formula says x minus h. So if we have x plus h, that means that h has to equal -4 in order to get this plus here, because the equation says minus. In order to get a plus, you have to have a negative right beside another negative. So h is -4, so you're going to move this graph to the left, -4. So 1, 2, 3, 4, right here somewhere. And also the k, this is how you move it vertically. If it's -2, I need to move it down 2. So I'm here at -4 and I move down 2. This is my new vertex. And it says that the vertex should be HK. That is HK. This is my new vertex. And then I still have the slope of +1 on the right side and the slope of -1 on the left side. And to compare it, because now it says compare the graph with the original parent function, I would say that it shifted to the left 4 places and down 2. And that's how you compare. So let's talk about stretches, shrinks, and reflections. So now we're not just talking about shifting, we're going to talk about actually shrinking the graph. This is going to happen anytime you have a number times your absolute value. This A stands for just some real number. You have some number times the absolute value. If the absolute value of that number is greater than 1, that means your graph is going to be vertically stretched, or it's going to be elongated, so it's going to be skinnier. Skinny. If you take the absolute value of A and it's less than 1, that means your graph is vertically shrunk, or it's compressed. It's going to be fatter. This is going to be a skinny V, this is going to be a fat V. Vertically elongated, up and down, this is vertically compressed. So it becomes very short. And then if A is ever negative, that means it's gonna reflect across the x-axis, or it's gonna flip over the x-axis, and that's if A is ever negative. So here's 2 examples. Y equals a half of the absolute value of x. A half, the absolute value of a half, so you just take the positive half, which it's already positive. It's less than 1, so that means it is vertically shrunk or compressed. And how you're going to graph this is it's not shifted at all, because there's no plus numbers over here, no h and k. The number in front of here just changes the slope. Instead of 1, now it's going to be a half. So you start at 0, 0, you're going to go up 1 over 2, up 1 over 2, same on this side. And this is going to be your new V. And you can see that it's fatter because it's vertically compressed. So if it said compare this to the graph of y equals absolute value of x, you would say it's vertically compressed. Now over here, if you look at -3 times the absolute value of x, if you look at the absolute value of -3, so 3, it's greater than 1, so it's going to be vertically stretched. It's going to be really skinny. And again, this is your new slope, the absolute value. You look at the absolute value of 3, which is 3. So your new slope is going to be 3. So you're going to go up 3 over 1, up 3 over 1. Same thing on the other side. But here's the other thing. This is not your finished product. This is not the graph that you're looking for. Because the number out here is negative, I said whenever it's negative, that means it reflects across the x-axis. So you're not done. You have to take this and reflect it over to the other side. So I'm going to take these points and make them negative. So this down here is now going to be down at -3. And this point's going to be down here at negative, well, you can't really see it because my graph doesn't go down that far. but you make these points negative. So instead of being this is 1, 3, it's now 1, negative 3. You're going to flip it over the x-axis. So now your v is going to look like that, and that is your final product. Because this is negative, you have to flip it over the x-axis. So let's put this all together. Now we're going to have both stretching and shrinking along with translations. We're going to graph this equation right here. Y equals negative 2 times the absolute value of x minus 1 plus 3. If it helps, draw the graph of the absolute value of x first. I know that the absolute value of x looks like this. Just a v with a vertex of 0, 0. My h is inside here. My k is outside here. My h is horizontal movement, h for horizontal movement, and my k is vertical movement. The number inside the absolute value is always the opposite, remember. So my h is not negative 1, but positive 1. And my k is just 3, that stays the same. So that means I'm going to move horizontally 1, so I'm going to move to the right 1, and I'm going to move up 3. So I move my vertex over 1 and up 3. So my new vertex is here at the point 1, 3. Then this negative 2, it's negative, so that means I need to flip it over the x-axis. So now that means it's going to be opening down. My v is going to be opening down. And I have a new slope of 2. 2 is greater than 1, so I should know that when I make my graph, it's going to be a skinnier x. And I'm going to have a slope of 2 instead of 1. So that means I'm going to go down 2 over 1, down 2 over 1. Same thing over here. And then connect your dots. You can see it's a little bit skinnier than if it had a slope of 1. And it's opening down because my number out here is negative. So that is your final graph. And then it says compare with the graph of y equals the absolute value of x. Well, one thing you know is that it's flipped. So you know it is reflected across the x-axis. You know that since there's a 2 out here, and it made your graph more narrow because it has a steeper slope, your graph is vertically stretched. Your two options are vertically stretched or vertically shrunk. We're stretched because it's elongated. And our vertex is shifted 1 to the right and 3 up. And that is how you compare it to the original graph. Should be your answer. So the example I want you to do in your notes is similar to the one we just did. I want you to graph this. It's translated horizontally and then down 2. And this negative 3 changes the slope of your graph. And then in the end, I want you to compare it to the original graph of y equals the absolute value of x.